Hi everyone, thanks for joining us today for a webinar on the future of robotics in STEM education. We have quite a diverse group joining us today, from educators, boys and girls clubs, libraries, after-school programs, summer programs, and more. I'd like to introduce Robert Grover, the CEO of PCS Adventures, as he will be hosting this webinar today.
And there we go, looks like we're live. Welcome everybody, my name is Robert Grover. I'm the CEO of PCS Adventures, and very excited to have you all here. As Dalton was saying in the introduction, we have a very diverse crowd, which I'm excited about. A lot of the enrollments that I was looking at, some people are just getting started in robotics, homeschool parents, and some people are quite advanced. We've even got developers that are involved. So again, welcome everybody. A little bit about myself. I've been with PCS Adventures since 1988. PCS is a company that's focused on experiential STEM education, and we've had a strong focus on engineering and robotics since the very first days. My first days at PCS, I met the original school founder, who was a teacher from rural Idaho. I walked in the door, he put me to work teaching, and actually we were doing robotics right then. So I've been doing robotics for a long time. Seen a lot of changes, and in this particular presentation we're going to talk about the changes that are going, that we're going to see in the future, where we're at right now, and talk about a lot of the things that that means for using robotics in the classroom. So a little bit about PCS Adventures. For those of you who are new to PCS, our core mission is experiential education. And really, if you boil that down, what do? We make children's lives better through engaging educational experiences. And we do that in lots of ways. We do that through curriculum and products that we create. We do that through labs that we operate. We actually operate our own classrooms. And we also do that through STEM consulting, custom development of programs. But the core of it all is making children's lives better. So the kinds of activities we see on this slide are a really good example. I selected an array of images from students that are using PCS robotics products and focused on robotics specifically for this presentation, so you can get an idea of the kinds of things that kids are doing. The thing that stands out more than anything, if you look at all of these images, is engagement, enthusiasm, excitement. That's one of the biggest pieces of using robotics in your education program. It can get kids excited about education. Little background on a couple of these pictures, which are fun stories. The upper left-hand image, which is black and white, is actually from around 1989. That was a student that was with me when I very first started. And you can see that he's actually programming a Lego robotic arm on an Atari ST. For those of you who are as old as I am and may know what an Atari ST is, you'll know just exactly how exciting that is. Robotics has come a long way, but kids are still doing a lot of the same things that I saw being effective back then. Second picture to the right, in the center, you'll see a student working on something on a hardwood floor. And this is an exciting one that I just wanted to talk about because it really personifies engagement and the kinds of things that come out of good robotics education experiences. This was a challenge that I posed almost 9 months ago to our students in the lab, and it involved a very simple challenge: create a robotic fish walker. What is a robotic fish walker? Well, it's essentially the same thing as if you were going to take your dog for a walk. You want to create a robotic device that will safely transport your pet fish and follow you. So it had to do all of this automatically. So the student, his name's Tristan, is working on it there. This is a neat project because it ties together a lot of the aspects of robotics that are so effective in education. So in order to accomplish this challenge, Tristan had to build a mechanical transport device, first of all, something that would move the fish. He had to know how to do the electrical wiring because it's got motors in it. He had to do some structural engineering so that it would safely hold the fish. And then, of course, he had to do all of the programming using the robotic controller. His end solution, which we demonstrated last week and awarded him a prize for, was really awesome. It followed him around. It used ultrasonic sensors to detect his position. When he moved, the robot moved with him and followed him, and the fish went for a walk, just as it was supposed to. No pets were harmed. So that's a great example of the kinds of things that come from robotics. Those are the kinds of activities that PCS does in our products and programs. So to wrap that up, our mission is to take what we do, which is making engaging learning experiences, and get to 10 million children a year. We want to do that through becoming a leader in K-12 robotics education, which I think the things we'll show you today is exciting and will give you an indication of how we're moving towards that goal. We also want to establish PCS STEM products in every elementary classroom. We have programs that are awesome, that teachers love, that can bring STEM to life in the elementary classroom easily and affordably. And we want to establish a global network of these labs that I was describing. We want to do that through partnerships with schools, with after-school programs, science centers, everywhere that hands-on science and technology education fits. We have a model that can help put these labs into place. Ultimately, we'd like to see hundreds of these labs around the country where kids can come and do hands-on activities. Finally, we want to tie all of those students together virtually using a network. And the common bond between all of them is experiential learning. So there's lots of social networks out there, things like Facebook and so on, where kids can communicate. This would be a community that the common bond is experiential learning. People are learning things, sharing things, and so on. So that's a little bit about PCS Adventures. And now what we want to do is move on to the webinar. So this is a quick overview of what's to come in our presentation. Today we're going to talk about, number one, why robotics in STEM education is important. And there are some significant reasons, which I think you'll find fascinating. Second, we're going to talk about my vision of what the future of robotics in STEM looks like, based on the things that are happening. And finally, we're going to take a look at how you can implement robotics in classrooms or in formal environments, and some of the tools that we use here at PCS Adventures to do that. Then we're going to do a quick wrap-up, give you an opportunity for lots of questions and answers, which we're excited about. And we're going to give away, at the end of this webinar, a free robot kit. So the Discover Robotics kit, which you'll see today in the demonstration, is going to go to one of you attendees. The only requirement is that you have to stay through the entire thing, because we're going to announce the winner at the end. You have to be present to win. So good luck to all of you, and again, thank you for joining us. Let's get started. All right, let's talk about why robotics is so important. Now, we've touched a little bit on this already when I was telling you about Tristan and we were looking at some of the other images of the students. The engagement aspect is huge, okay? It's an enabler, it's a natural platform for kids to learn science, technology, engineering, math. All of those things are neatly dovetailed and woven into robotics because you have to do so many different things to get a robot to work. So, students find STEM engaging when they're attached to robotics projects. One of the things that we know is that we need more people getting into STEM careers. We need to get kids excited about STEM. This is a great way to do it because of that engaging aspect. Okay. Second of all, which I just touched on, interdisciplinary. There are natural connections to all of these subject areas. So you can do lots of cross-curricular ties, everything from language arts to math, science. It's all there. Some of those examples you'll see today. The other thing I like to emphasize is 21st century skills. So in particular, things like collaborating, problem solving, being able to think critically. One of the things that we do in our labs, we use a framework called the Habits of Mind, which is a great framework for emphasizing 21st century skills. And we apply all of those when we're working in robotics. So a good example, we call it failure-based learning. If the wheels come off your robot, well, that's normal because what you have to do is work through challenges and solve those problems. And that's a good example of 21st century skills, perseverance. You have to be able to solve problems, work together, communicate. Okay, third, why is robotics important in the classroom? It's relevant, okay? How many of you have heard, why do I have to learn this? Why am I doing this? This is a waste of time, this is boring. Well, this shows students exactly why they're learning the science, why they're learning the math, and why they're doing these activities. A lot of times they don't even stop to think about it because they're engaged, they're having fun, and they're trying to solve a real-world problem. So it's relevant. It ties the academics, the theory, to the real-world application. And finally, which goes along with our 21st century skills, it requires in-depth problem solving and critical thinking. We want students to be able to think outside of the box and not just solve rote problems. So that's the first slide about why robotics is important. It's an engaging and enabling education platform. Second big point, why it's important for education in STEM areas, is it's inspirational for jobs in computer science and other STEM career areas. So let's take a look at this graph. This is a fascinating insight into how many students are graduating in computer science and how many students are needed in computing jobs. So there's a lot of research, there's a lot of discussion, there's a lot of news coverage that we need more students in STEM. This graph is quite visceral in terms of demonstrating what we're lacking. And we're lacking that because students are missing the engagement aspect in a lot of cases. We need to show them that STEM fields are exciting, they're rewarding, they're engaging, and we can do that through robotics. So that's the second big reason why robotics education is important. Third big point of why it's important in the classroom, it's one of the fastest growing industries on the planet. So for those of you who are following robot news, you know, robots are everywhere. You've no doubt seen, you know, ads about Amazon's drone package delivery. There's a great example of robotics in the workplace. Robots are showing up in agriculture, they're showing up in defense, they're showing up in medical applications. Just about anywhere that you can imagine, robotics is beginning to permeate. We've even got robotic vacuum cleaners. So, as one of the fastest growing industries on the planet, and a technology that's becoming ubiquitous, it's showing up everywhere, we'd be doing our students a great disservice if we're not training them and preparing them to be technologically literate about robotics in society, because it is growing so quickly. So with that in mind, let's take another look. These are just some headlines that I grabbed just last night when we were preparing for the webinar. It took me less than 30 minutes to go out and grab headlines that filled this page. There are a lot more. Now, a lot of people will look at these headlines and they get afraid. Oh my gosh, everybody's going to be out of work. I look at it in a much different light. We're looking at a transition. We're transitioning from an environment where there's lots of hand work being done by individuals. It's being replaced by automated machines. It's not something that we need to be afraid of. It's not something that, you know, we need to have a lot of concerns about. What we need to do is prepare students for it, because the work landscape is going to be much different in 20 years than it is today. We can prepare students through familiarity and through technological literacy. If they understand how robots work, what they do for us, it's a much simpler issue because then they can look at, where do I fit into the scheme of things? I'm technologically literate. What kind of jobs can I do? Maybe it's in supporting robots, maybe it's in designing robots, and so on. However, it's inevitable. The change is happening, automation is there, and again, we'd be doing our students a great disservice if we weren't preparing them for that. So, fascinating survey. If you have a minute, go out there and just do a quick search for robots in the workplace, and you'll get all kinds of fascinating hits. Okay, so let's move on to the future of robotics and STEM. We've talked a little bit about why robotics is important, why you should get it into your STEM education program. Now let's take a look at how to do that and what the future of robotics might look like in STEM. Compared to when I first started in 1988, there were 2 platforms that I could use other than ones we built ourselves. Today, you have lots of choices, and there's going to continue to be more and more. I've put together just a couple of slides to give you an example of the vast array of opportunities to get into robotics that are out there. On this first slide are some of the most popular systems. You can see Lego, Tetrix, Vex, there's Fisher Technic down at the bottom, Connex Robots, OE. Lower right-hand corner is a really cool company from Cyprus. It's called Ingeno. He's got his own robotic system. And then in the upper right-hand corner is the one that we're going to be looking at today. This is PCS Robotics. That little build right there, we call him RIQ, Robotics Intelligence Quotient. And he's a lot of fun to work with. You'll get a chance to see how we use RIQ today a little bit. Let's take a look at some more robots that are out there. I put 3 slides together just to give you an indication of how many choices there are and the vast array of opportunities there are to get into robots. So these are not along the same high polished level of the first slide that I showed you. Some of these are do-it-yourselfers, some of these are quite inexpensive, some of them are complex. They're all over the board. The one in the lower slide, the humanoid looking one, is called Neo, And he's a fascinating one. He's very sophisticated, he's very expensive, but he's also very fun. You can do all kinds of things with Neo. So there's this broad range of very simple robots that might be two-wheeled, clear up to these sophisticated humanoid robots that move and dance and do all kinds of crazy things just like a human. Here's one last slide. This is actually just a screen capture from a Google search, giving you another indication of the vast array of kits that are out there. So lots of opportunities for you to get involved in robotics. They range from very simple to complex. And one of the things that is part of the future of robotics is prices are getting lower. It's more affordable, it's more approachable. This slide talks a little bit about what lower prices mean. So there's essentially a scale. At the bottom of the scale, where they're the least expensive, typically the materials are not going to be as robust. Okay? So they might not last very long. It might be a simple do-it-yourself kit that might have balsa wood and things like that. Might be a consumable. It's a one-time build. It might also not be programmable. It may have just one function that it does. The programming function is, of course, critical from the perspective of really getting kids involved in robotics, because that's where a lot of the problem solving, the critical thinking comes from, is actually learning how to program and control the sensors and the devices. Fewer features at the lower price points. As you get into more expensive systems, they're much more expandable. You can add on parts, you can add on sensors, you can add on capabilities. So that's the range. You know, part of what we'll talk about a little bit later is when you're trying to figure out, okay, what materials do I want for my robotics program, is what's your budget and what are your objectives. One of the nice things about some of the more expensive systems is that they're very durable. So as opposed to consumable, where you might need to buy things over and over again, the others, they're more expensive, but they represent an investment that will last for many years. Okay, Future of Robotics in STEM Education, slide number 3. Robots are going to be ubiquitous within STEM education. I consider them already to be there because of the circles I travel in, but lots of places still need to get robotics programs implemented. As of now, we know we have homeschoolers using robotics. We have lots of boys and girls clubs using robotics, one of my favorite organizations. YMCAs, after-school programs, classrooms, of course. Libraries and makerspaces are really catching on as a great place to have hands-on robotics available. Girl Scouts, Boy Scouts both have different merit awards for getting into robotics. 4-H clubs now have robotics programs. It's not just about ag anymore. Also robotics clubs, competitions. You know, ubiquitous is the word, I think, because it's everywhere. In fact, we now have a National Robotics Week. For those of you who didn't know about it, it's in April every year. I think this year was the 4th or 5th consecutive year. And it's designed to really elevate awareness of robotics as an industry and how it's placed in our United States, so people can be more familiar with where robotics is going and more familiar and comfortable with robotics as a potential career. So another point on future of robotics, communications and system integration. One of the things that happens, of course, over time is technology becomes more sophisticated, becomes less expensive, more powerful. These things enable you to do much more sophisticated kinds of things with your robots. You know, in 1988, the kinds of things we were doing were quite simple. We had a lot of the same kinds of sensors I'll show you today, actually, but we did not have the capabilities or the access to technology that we have today. A couple of examples. So that middle slide, which shows a number of multicolored robots, that's what we call swarm technology. Okay, these are all individual robots. They each have their own little individual address so that you can talk to each one of them. But they also collectively work together. So they can communicate, they can act as one, they can actually accomplish tasks as one. This is a fascinating thing to watch. Again, it's called swarm robotics. If you were to do a search on the internet, look at YouTube swarm videos, you'll see some fascinating things. Lower right-hand corner, the logo for the Globe project, which is it's an international project that leverages what is called citizen science. For those of you who haven't heard of citizen science, it's the ability for us, regular day-to-day people, to participate in scientific work. It might be gathering data and submitting that to a bigger project that can then be used. And that's what Project Globe does. Project Globe actually takes advantage of students from all over the world. Students can go in and select a specific project they want to participate in, And they may use sensors to gather things like pH data, temperature data, humidity, and they collect it at a specific location. Again, with data such as GPS coordinates, you can provide exact time, position, and all of that other sensor information that you can then submit to Project Globe as a whole. You have thousands of students out there submitting this data. It evolves into an incredible tool for actually doing real science and cataloging things that may be going on in the environment, for example. So the communications and system integration aspects of robotics is going to continue to grow. Some of the most exciting things for me personally as we continue to evolve our Adventures labs is things like smart devices, so devices that recognize you when you walk into the room. Using vision processing, you can have a system recognize you, turn on your robot, it can wake up, bring your fish over, greet you, and you can get to work in the lab. Upper right-hand corner, this is another neat one. If you look up the Microsoft HoloLens, this is an example of advanced technology where they're combining physical robotics, which if you look on the floor of that image, you can see a little physical robot that would be driving around. Okay, very simple. On top of that is actually a virtually generated image. To see this, you have to have goggles on, and it creates a hologram, a three-dimensional robot that overlays the physical robot. And you can also see floating in the air next to that robot the control panel, so you can actually interact with that virtually, control the robot, program the robot, and see the robot. The other things that this does is it combines environmental awareness with more processing power. So a lot of this can be outsourced to the cloud so that, for example, environmental information, the terrain or obstacles can be communicated from a more powerful computer to that little robot. He doesn't need to have the brains to actually process or crunch all that data. He can just take that information from the cloud. So the communications and the integration of those kinds of things, incredible things are coming. So that's a piece of the future of robotics in STEM. All right, let's get on to some examples. One of the things that's most exciting for me, having worked in robotics for so long in the classroom, is the products are becoming so much easier to use. Okay, we have plug-and-play hardware, we have drag-and-drop programming, both of which I'll show you. And it makes it a lot easier for people who are maybe not necessarily technically trained or might have some sense of intimidation about getting involved in robotics. It makes it a lot easier. If we take a look at this slide, this is an example of what we call plug-and-play hardware. The image on the right is the microcontroller from PCS Adventures, and we call it the PCS brain. And you'll notice there are a number of ports on the side. There's a little label underneath it called sensors, and that is where you plug in the different types of sensors that you would want your controller to be reading. In the center, I've put some images of the sensors that come with our Discover Robotics package, which we're going to look at here in a moment. It includes touch sensors, little buttons, LEDs, which light up very bright, infrared sensors, which can be used to detect differences in reflection. Typically you use them for things like line following applications, where it's bouncing a signal off of the floor and it's looking for, say, a dark line versus a light surface. Light sensors, where it senses the amount of ambient light. We have a little project called ScaredyBot. When the lights go on, it gets afraid and it runs for a dark corner. So things like that. But again, plug and play, they're very simple to attach. So the sensor ports, plug into those with very simple cables. They have little stereo plugs on them, just like you would plug in your microphone with, or your headphones to your iPhone. Little stereo plug connects those guys. On the left-hand side, same concept. You've got a stereo plug, and then you've got motor plugs. Those are Fisher Technic DC motors. So connecting motors, sensors, getting it all hooked up is very simple. This is a little bit more information on the PCS brain so you can see the other ports. Again, I was pointing out in that image the sensor ports, of which there are 8. On the bottom of the image, there are 4 ports for what we call servo motors. For those of you who don't know what servos are critical in robotics because they can control movements very precisely. So you can adjust a movement to 30 degrees or 90 degrees. And that's how you can create robot arms and things like that that are very precise in picking things up and moving them around. So servos are very important. DC motor ports are on the right-hand side, 4 DC motors. And DC motors are the simple motors that drive things. So if you've got a robot that needs to run around on the floor, typically it'll be DC motors. Your servos have much more granular control depending on the application. So plug-and-play hardware, again, very simple to attach devices, and then you move on to actually programming those devices. So now what we're going to do is take a look at how simple it is to program these days. So drag and drop programming is just what it sounds like. You're dragging images that represent coding blocks, connecting them together just like puzzle pieces, and the end result is what we call a string of code that's going to execute a program. So a program, just for those of you who are new, is a set of instructions that your brain, your computer is going to follow. So you can create very simple instruction sets using what are called drag and drop environments. What we're going to do right now is switch computers so that you can actually see this demonstration. Technically, I haven't done this before, so let's hope this works smoothly. Hang in there. Okay. And panelist, right? And there we go. We've switched computers. And my technical crew has given me the high sign. It sounds like it's working. So here what we have, actually I'm going to start fresh, is the programming environment called the Cortex, which comes with our robotic brain, which I was just showing you the pictures of. Cortex is very simple to use. This is actually version 5 of the Cortex. We're very excited about it. It's maybe one of the best programming environments in the world. If you ask me, I believe it is the best. It works on all platforms, works on iPads, works on Android devices. The capabilities on tablets are awesome. You can do some really neat things with it that you can't do elsewhere. And it's one of the only programming environments that you can do on tablets that I'm aware of. So the Cortex, let me give you a quick example, is color-coded. Again, it's drag and drop. So I've just popped out a menu called motor commands that you can see here. This next set of commands has to do with procedures where you can create subroutines, call variables, make variables. The blue menu is where we call sensors. We also have numerical operators in there. Green stuff is my favorite. Logic commands where you create loops and decisions. And then finally we've got some fun things under miscellaneous, things like the note command where you can teach the brain to sing. So let's create a quick program so you can see how simple it is. I'm dragging these items around. I'm going to zoom in a little bit. You see how easy it is to zoom in. I'm just using my mouse to zoom in and get a closer look. On a tablet you can pinch and zoom in or out on different sections. So now I'm dragging in my first control block. This is a motor A command. And what that means is it's addressing motor port A on the brain. If you recall what the brain looked like in my demonstration a few minutes ago on that previous slide, it had the 4 DC motor ports. I actually am going to turn on 2 of those DC motor ports here. So you'll notice now I'm talking to port A and B. Great. So that's the first part of our program, but talking to motor port A and B doesn't really do anything for you. We have to actually tell it to do something. So what we're going to do is turn those motors on for a period of time. I am told to slow down my drag and drop. Sounds like there's a little bit of lag out there, so I'll slow down the programming a bit. I'm grabbing a number operator now and moving it out here onto the screen. And you'll see how I'm attaching it to this little pin that sticks out from the on4. And as a number operator, it's something that I can use to enter a variable or a number. So in this case, I'm going to enter the number 50. The Cortex calculates in tenths of a second for operators like that. So if we divide 50 by 10, that means it would turn motors A and B on for 5 seconds. And then I'm going to attach end, and boom, my program is complete. Very simple. So again, as an approachable way to get students started with robotics, there's nothing more simple. And when you integrate things like tablets and a lot of the fun side of this, you can see how visually appealing the environment is. It was actually built in a gaming engine, so a lot of the things that we've built into the Cortex have a lot of game appeal or engagement for the students. A couple of neat things about teaching tools. You can expand out the actual code. Our system is based on the Arduino platform, so what you're seeing here is actual Arduino code. One of the things that we're trying to do, of course, is create an enabling platform that's going to take kids from an easy environment, a very approachable drag and drop environment, and migrate them into more technical coding environments. This is a great segue to do that, and this is a great teaching tool because you can pop this open anytime and actually see what the code looks like. One last feature I'll show you in the Cortex is great fun. We call it the virtual UI, which stands for user interface. Students can actually build their own control panels to drive robots. So for example, the green physical sensor menu here, I can pull out a few representations of different sensors, such as the light sensor or the infrared sensors or the ultrasonic, and these will read out in real time as your robot is moving through an environment. So building a little control panel is very simple. Another neat aspect of this is what we call virtual sensors, which are built into the actual programming device. If I were using a tablet, it would be using the tablet microphone. Since I'm using the computer, if I had my microphone unmuted, you would actually see the sound level moving up and down, so you could actually program your robot to respond to your voice. This is one of my favorites. It's the accelerometer. Won't work on my laptop, which I'm demonstrating here. If you had a tablet, this rolls around. It looks like a big eyeball actually, and actually shows you the positioning of your tablet. And you can take those coordinates. In fact, I've got one here. You probably can't see it very clearly, but as you move this, you can see the accelerometer moving with it. And basically you can take the data from that accelerometer, feed it back into your program, and you can literally drive your robot around using your tablet. A lot of other fun things you can do. You can incorporate the built-in GPS of your device if it's in your tablet, working compass. So a lot of fun things in this virtual UI where you can actually build a complex control panel. The last thing in your control panel is virtual controls, things like slider buttons. You might have a motor connected to that or a light. Virtual joysticks where you can actually control something and drive it around. A lot of neat, very simple to use tools that are within the virtual UI and within the basic programming environment. So here we are again back on the slide, drag and drop programming. You've seen an example of that. Hopefully it has imparted how easy it is to use. I've used it a lot, so obviously it's pretty quick for me. But to pick it up, seriously, students are programming within minutes. One of the first activities we have them do is build a small motor testing station. They learn how to turn motors on and off, run them forwards, backwards, control the power in them, and they do a number of challenges around that, mastering motor controls first. So very simple to use, very approachable. So we've talked a little bit about the future of robotics in STEM education. Let's talk now about how you actually implement robotics programs. Again, to reiterate, in my opinion and the opinion of most people working here at PCS, because we love it so much, robotics is the perfect subject area for really facilitating student-driven experiences, high engagement activities, and really accomplishing a lot in terms of getting kids excited about STEM fields. It's a great platform for problem-based learning, challenges, self-guided discovery. In our labs, we have a facilitation model where we get students started. We walk them through a student experience really where we start with the basics. They learn step by step how something works, and then we migrate them into challenges fairly quickly. So we want somebody to have a solid understanding of the concepts that they have to understand, but then we want to move them quickly into a challenge environment where they're applying those. And then each curriculum unit that we do culminates with a design project where you're actually applying it. These are a couple of things I put together for those of you who are just starting in robotics. As you prepare your program, there are a lot of different kinds of things to take into account. At the end of this presentation, I'm going to show you how to get in touch with any of our salespeople. Our account managers work with our robotics programs all the time, and they can help you figure out what might work best in your particular environment. Some of the preparation questions for you to keep in mind is, first of all, what are your objectives? Are you actually implementing this in a classroom environment and you want to align with next generation science standards, augment your Common Core? You need to think about, is it more of an informal experience in a boys and girls club, what you're trying to do typically, it's great to have it aligned with Common Core and next generation science standards, but you're really trying to engage and get kids excited about science and engineering and teach them something. So your informal environments are maybe more flexible, and we've got tools that actually fit well into that environment, which I'll show you here in just a moment. So what are your objectives? Is your environment formal or informal? Another thing to consider is how much time do you have available? How much time do you need to fill in your program? Do you have a specific set of contact hours that you need to fill? Or is it going to be an open-ended system? Good example is here in the lab, it's much more open-ended. We have what we call a merit system where students can work through levels and work literally for years. We've had students that have gone through multiple levels and are doing very sophisticated kinds of things. This can work well in an informal environment. You know, Boys and Girls Clubs, for example, can actually execute this program if they have students that can come and continue to avail themselves of the program over a longer period of time. Another thing, of course, to consider is your technical proficiency, and do you have technical support available? If you've never done anything like this, if you've never programmed, don't be scared of it. It really is fairly simple to get started, but it always helps to have a techie that can help answer questions. We have a great tech support person and training director. His name's Jesse, and he loves to talk people through issues where they're just getting started, loves to talk about it, and he's taught in many environments, so he feels your pain, let me put it that way. Final thing to consider, you know, what is your budget? Are you going to be looking at something that's going to be on the lower end, like we were talking about, maybe consumables that you might have to buy each year? Are you going to be able to invest a little bit more for materials that you'll have year after year? You know, you have to think about what is your availability. You want to create a program as much as possible that's sustainable as well. So all of those are good prep questions for you as you're thinking about getting started in robotics. So let's continue on here. I'm going to talk to you a little bit about our core robotics kit. We have a series that we're releasing, and our approach to robotics is a little different, I think, than many companies. We look at robotics as a core enabler that you can teach lots of things with. You're not necessarily just teaching robotics. You're not teaching just computer science. You can teach applied mathematics. You can teach all kinds of applied sciences. A lot of neat things that you can do using it as the tool of engagement. So with that in mind, I'm going to show you first of all our computer science package, and then we'll talk a little bit at the end of the other programs that we're working on. So the Discover Robotics Kit is the core package. Looks like this. Get it up here so you can see it. It's about yay big. It's in a very nice sturdy case, and one of those is designed to support anywhere from 1 to 3 kids depending on your environment. We have 2 sets of curriculum that work with this same kit. And one is more classroom, formal oriented, which is called the Discover Robotics Classroom Curriculum. And then the others are the lab cards, which is a very simple to use curriculum, which I'm going to actually give you a few examples of here as we go through. So one kit, 2 different ways to apply. Some of you who may be considering district-wide programs or school-wide programs, you may want to actually buy the kits and both curriculum, because you may have after-school environments that want to have more access to things like the card series. Plus you may have core classroom teachers who want to get into the richer curriculum, which we'll explain here as well. So think of it as a modular system that you can put together to meet the particular needs of your environment. So let's talk about lab cards a little bit. We specifically designed these around the system that we use in our Adventures lab. It's very granular, very differentiated instruction, so students have the ability to go as quickly or as slowly as they might need to. There's lots of help there, so we want to try to make it as independent an experience as possible. This is what a lab card pack looks like, and essentially students, if they're just getting started, would come over here and grab the very first card out of the pack, and they would go through and follow the instructions. And it follows the sequence that you need to actually learn how to turn on the Cortex, use some of the things that I was just showing you in the drag and drop environment, how to connect your motors. So it starts with, again, very granular step-by-step instructions, migrates to more open-ended challenge type projects. What we want to do again is take that student through basic understanding and comfort with the materials, and then get them to a point of mastery and ready to move on to the next card. So with assessment, they're a breeze because we've also assigned a point system to each of the cards. And essentially, the more cards student does, the more points they accumulate. So to summarize, the lab cards curriculum, it's better suited probably for more differentiated or student-driven environments. After-school programs are ideal. We find that a lot of classrooms actually like them as well because they are very flexible. They give the student all of the material they need. Each card has a series of projects and challenges that really, again, gives you the core material you need to get started, but also pushes you to challenge yourself and solve problems. And finally, it's designed to build skills with each card level, so it stair steps up. Essentially, they get more and more sophisticated as they work through the card system. Now, the Discover Robotics classroom curriculum, it is based on the same activities as the cards, uses the same kit as we mentioned, but it's designed for classroom instruction. There's actually an instructor version and a student version. It is designed for several different types of application and assessment. So it has a very rich journaling, reflection, peer-assisted review process in it that you can use for actually developing authentic understanding. The assessment models, which are included in the books, we have a standard multiple choice standardized test that we aligned with the next generation science standards. So if you need something like a standardized test, that's available within it. And then there's also the rubric-based authentic assessment, which is a much richer experience, but takes more work on the front end to prep for. It's a much more effective solution for students. It's the one that we practice here. We highly encourage it. It may require additional training to implement if you're not familiar with it. But the amount of resources that are available between these two curricula give you everything you need essentially to run a very successful robotics program. So finally, to summarize, the Discover Robotics kit itself, again, they come in this plastic container, and it includes everything. So you get sensors, you get the controller, it includes the software. A lot of systems you have to buy the software separately, or there's licenses that you have to get. You buy our kit, the software is included. It's an unlimited software license, so you can load it onto tablets, you can load it onto your computers. It really makes things easier in the classroom so that you can have access to the software anywhere. And there are many bundling options. We've created a lot of different solutions over the years to make access for robotics materials and engineering materials quick and easy for educators. So for example, on the low end, you can buy one kit that you might be doing as a homeschooler, or on the high end, you may be buying one of these complete with a storage unit, and we throw in additional curriculum resources like challenge guides and things like that for classroom applications. So there's a broad range. Again, the people that I'll introduce you to at the end of this presentation can get you real specific information on pricing and what materials you might need to get your program going. Finally, to summarize it, using either one of the curriculum or both, it gives you the ability to bring robotics into pretty much any educational setting. And finally, to wrap up, I had mentioned other products. Again, we look at robotics not as an end to itself. It's really not about the robot. It's about the process. It's about the concepts that you're imparting when you're using robotics as the platform. So computer science is the first curriculum that we've released. That's the one that we were just talking about, and it's a natural, of course. The next one that is available this summer, Discover Robotics and Physics, actually does a lot of fascinating things with applied science. We use Fisher-Technic materials, the pneumatic system, and we incorporate a lot of different things about forces, air pressure, pneumatics, and then of course things like the pneumatic catapult. You get all kinds of interesting levers and other forces involved that are a great hands-on explanation of physics. You tie all that together with robotics, where you're actually programming and timing the launching and things like that, timing the use of the compressor. It's a really interesting interdisciplinary unit that gets kids excited about physics. So we're excited about that one. The one that we're working on after that is an applied mathematics series where we use the brain and we use devices like robotic arms to talk about the geometry, things like polar coordinates versus Cartesian coordinate systems. A lot of fascinating applied math and things that you can do, again, using the robotic system as that tool of engagement, the thing that's going to get people excited. So finally, time for questions, and then we're going to announce the winner of a Discover Robotics kit. Dalton, do we have any questions that people have been asking?
Yes, we do. Thanks, Robert. It looks like we had a couple of questions actually before the start of the webinar in our comments section. So the first one is, excuse me, how can we get funding for STEM programs like yours?
Depending on your program, there's lots of school budgets that robotics fits into. There's also a lot of different grants and different opportunities for getting funding. We've worked on all scales in terms of grants, things from federal grants down to just local bank grants. This would be a great question to ask your local account representative. We actually have on our website a list of grants by state, and most of our account reps are going to be able to talk to you very knowledgeably about what might be available in your area. So I'd start there.
Second question here, how to teach robotics with collaboration from teachers?
Teaching with collaboration from teachers. If we're talking about, we may be talking about team teaching or doing a school-wide implementation. Some of the things we've done with programs is, which is a great event, you can turn it into a school open house or a Boys and Girls Club open house where you have multiple teachers that are working with the kits and they're all working on a challenge. And at the end, during the open house, everybody unveils their solution to the challenge. That is a great way to do collaborative projects between teachers because you're focusing on similar things in other classrooms.
All right, and the third and final question is, I would like to know more about the future of robotics in STEM education and how to buy it for my organizations.
Again, that's very simple. The next slide, in fact, I think gives you an overview of the salespeople. And all of this information is on our website as well, or you can call into our 800 number and we'll make sure we get you connected to the right person. Susie Hayslip is local here to Idaho. She's been with the company for 10 years, and she's an expert on robotics. So she's got a great grasp on all of this material to help you craft a solution. Jeff Sweet, also an outstanding STEM evangelist, I call him. We've got Sharon in the east, and then we've also got Stephanie and Michael Brown. We also have additional reps that are out there that we can connect you with in select areas. Michael Brown is our Director of Sales and Marketing. He can actually help you get connected to folks.
Looks like we have another question here. Is there an assessment along with the lab cards kit? Is there future engineering applications with robotics?
Is there, okay, let me take that one at a time. Is there assessment with the lab cards? The answer is yes. It's a point-based system. So essentially, as you complete activities, and it's a facilitated event. You know, as students complete activities, the instructor checks off basically if they got the activity completed. Once the card is done, then it's a point-based system, and they get X number of points based on the complexity of the project. So very simple. It does encourage facilitation, discussion, and the instructor has to be, you know, that guiding force that has that student really accomplished what that card is trying to impart. What was the second half of the question?
Let's see. Is there future engineering application with robotics?
Absolutely, yeah. A lot of the series that we're releasing, things like the applied math and applied physics, both have applied engineering within them. We also have a number of curriculum modules that we're releasing for the Adventures Lab program that are specific to mechanical engineering, structural engineering, statics, dynamics. So the system that we use primarily, we actually work with a number of different manipulative systems. We use Lego, for example. Fisher Technic is the one that we use primarily. It's very robust for both construction engineering, if you're building structures, teaching statics. It's also very robust mechanically, so you can create some pretty amazing machines with it. But yes, lots of engineering applications.
We've got another question. Does the curriculum come with the kits or is it sold separately? If sold separately, how much does the different curriculum cost?
Again, talk to your representative. They can get you complete quotes. Basically, we sell the kit with one version of the curriculum, and you take your pick of which one. And then you can add the second one on if you need both of them.
It looks like I'm going to return to an older question. Does it connect with older robots, the Cortex?
The Cortex only works with the brain, if I understand the question correctly. Now, the brain itself was specifically designed and engineered to work with older systems. I'm actually going to hold our robot up here, our little guy here. You can see he's got a lot of different parts attached to him. Some of those are Fisher Technic. But you'll also notice that it has the stud dressing for connecting to Lego. It's also got the holes for connecting to Fisher or to Lego Technic. It's also got adapters for connecting to things like Connects. You can bolt it onto Vex, Tetrix, erector sets. You can bolt it onto your robot that you built out of 2x4s in your garage. You know, we created this with a very open hardware mentality so that it would be something you could integrate into legacy materials. If you've got a closet full of old erector sets, for example, you can actually use this system to bring it to life.
It looks like we've got another question. What competitions are available for your product?
You know, we provide a challenge guide where you can run your own competition, essentially. And it's a pretty neat, flexible model because competitions, in a lot of cases, can be too expensive when you combine all of the travel and everything else that goes into it. The challenge guide that we provide gives you a number of different things that you can actually do in your classroom or in your after-school program or even within your district. You can organize, using this challenge guide, a series of competitions where different schools, for example, could compete. Having said that, using this system and this curriculum and the lab cards, for example, is absolutely great training ground for anybody who's going to compete in any of the bigger national competitions if you're going into FIRST Robotics or any of the others that are out there.
Will the Cortex/brain work with non-PCS Adventures manipulatives?
The brain does. As I was saying, it'll connect. It's got physical hooks for just about everything. So yes, you can build it into Lego, Vex, Connects, you name it.
All right, it looks like we don't have any more questions. Thank you for joining us. And it looks like we have one winner.
Time to announce the big winner? Okay. Outstanding. Oh gosh. Is that Dawn Schuldenfrei?
Yes, it is.
Dawn Schuldenfrei has won a Discover Robotics kit. Congratulations. And where's she from? Anybody know?
It does not say, but
Doesn't
we hope
say.
that you'll reach out to us.
Great. Thank you very much for joining us today, Dawn, and everybody else. We really appreciate your interest in robotics. We appreciate your taking the time to learn about PCS Adventures. And please get in touch with your sales representatives and learn more about the products that might help you. Thanks, everybody. Take care.